In this question, a diagram is given which has a pole and a platform and 3 points. O is basically your origin, A and point F, which is on the top. So the question states one of these ropes is attached to the platform at point A. The rope forms a straight line from A to F. All right. Part A, find AF vector. AF vector is basically a vector which connects 2 points. So let's revise. How do we find such a vector which connects 2 points? So have a look. Whenever we have two vectors, let's say OA and OB in the vector notation having the I and j components, A and B are 2 points. If you connect A and B with a straight line, and let's say we are supposed to find a B vector, so we do B minus A. So we take the entire OB vector, which is B1 I cap plus B2 j cap. We subtract that with OA vector, which is A1 I cap plus A2 j cap. OA and OB, both of them, we can write it in the column notation. So OA can be written as A1, A2, and OB can be written as B1, B2. And hence AB vector will be B vector minus A vector. So we subtract these two. B1 minus A1 will be the X component. B2 minus A2 will be the Y component. And that's how we find a vector which connects 2 points. Back to the question, part A, find AF vector. So let's figure that out. Since we have to find AF vector, we will do F minus A. Right? So F in this case is already given 005.8. So let's write that in the column notation. Minus A vector is also given the coordinate wise, right? So let's represent that in the column vector notation. So this is this. And that's it. Now let's simplify this. 0 minus 3.2 will be minus 3.2, which will be the x coordinate. 0 minus 4.5 will be negative 4.5 being the y coordinate, and the z coordinate will be 5.8 minus into minus. So this will become plus 5.8 plus 0.3. So which will become 6.1. So that's the answer for part A. Part B, we have to find the length of the rope. So the rope in this case is AF. So all we need to do is figure out the length of this line segment AF. So how do we do that? So length of the line segment AF is nothing but the magnitude or the modulus of AF vector. Modulus represents the length of that particular vector. And since we have the x, y, and z components of the vector, so we use the formula. We'll go minus 3.2 squared plus minus 4.5 squared plus 6.1 whole squared. So basically we have done square root of x square plus y square plus z square. And if we simplify this, we are going to get approximately 8.23 meters as the answer. Coming to the C part. In C part, we are supposed to find the angle FAO. And how do we find angles? We will use the principle of dot product. So let's move ahead. So for part C, let's revise the concept. How do you even find the angle between two vectors? Using the dot product. Since we already know the formula of dot product, A dot B is mod A mod B into cos theta. So in this, if we make theta as the subject, we will get cos inverse of A dot B in the numerator, and in the denominator, you have the magnitudes of both the vectors, right? And so in this case, we have to find angle FAO. Let me plot that. Let's say this is the angle theta. So how do we do that? First, you need to figure out which two vectors are being talked about. So let's say A, we already found AF vector. So one vector is AF vector and the other vector will be AO. So let's write. So the angle which we were dealing with is theta is between AF vector and AO vector. So AF vector we already found out. So let's write that down. Minus 3.2 minus 4.5 6.1. And AO vector. AO vector can very easily be written as O vector minus A vector. So like we did in the part A, AF was F minus A. In this case, AO will be O minus A. O is the origin, which is 0, 0, 0, and A is 3.2, 4.5, and minus zero point 0.3. So the coordinates of A were already given in the diagram. So simplifying this, your AO vector will become minus 3.2, minus 4.5, and plus zero point 0.3. So now we have established the two vectors between which we have to find the angle. So now let's try to use the formula. So we'll do cos inverse. In the numerator, we will have the dot product between these two vectors. Let's find the dot product between AF and AO. So we'll write AF dot AO vector. AF we found out over here, so which is minus 3.2, minus 4.5, and 6.1. We take the dot with AO, which is over here, minus 3.2, minus 4.5, and 0 0.3. And now we take the dot product. So the principle, how to get the dot product, we multiply the x components together, the y components together, the z components together, and then we add everything. So multiplying the x components together, minus 3.2 multiplied by minus 3.2, will get 3.2 whole squared. Then minus 4.5 into minus 4.5 will be 4.5 squared. And the third term is 6.1 into zero point 0.3. And finally, we add all of these terms. And now if you simplify and get an answer, we'll get 32.32 as the dot product. So this dot product we can write in the numerator. So let's write 32.32. And in the denominator, observe, we have just the magnitude of the two vectors. So AF vector, the magnitude of AF vector, we had already found out as 8.23 meters. So let's write that 8.23 multiplied by, now B vector, the second vector in this case is AO vector. And AO vector is this. So let's figure out the magnitude of AO vector using the same formula, square root of 3.2 squared plus 4.5 squared plus 0 0.3 whole squared. And now if we simplify this and put that in the formula, we will get a value of theta. So eventually the value of theta which we should get after taking the cos inverse is 0.71 radians. And that is the answer to part C of the question, which was this angle theta.